Welcome. This is the second of two videos, so if you have not watched the first video, you should probably go back and watch that now. So we are still dealing with the same food storage company that makes cylindrical cans with a volume of 600 milliliters, so that's 600 cubic centimeters. And before we were assuming the cost of the top and bottom of the cylinder as well as the side of the cylinder was the same. We're not assuming that anymore. We're assuming that the materials for making the can cost this much for this tops and bottoms and this much for the wall. And we want to minimize the cost. So we still want that minimal surface area. That's our objective. So minimize cost. And our constraint is still volume. And from that first video, we know that we can write that out as H equals 600 over pi r squared. And that was beginning with the volume formula for a cylinder and the given volume for the can. So if you don't know where I got this from, you should probably go back and watch the original video. It should be coming up at the top of this video now as a YouTube card. And I don't remember, it's either this side or this side, but it's somewhere up here. So what is how can I express this objective as an equation? Well, the easiest way to think about it is money times area. And we know that the surface area of this cylinder, and again, we did this in the last problem, was given by the area as a function of radius as 2 pi r squared plus 1200 times r to the negative 1 power. Now, this came from the top and bottom, and this came from the sides, that is the wall of the cylinder. Well, we are told that the sides, let's see, the wall of the cylinder here is our cost, and here's our cost for the top and bottom. So that means the cost times the area as a function of r is equal to 0.005 times 2 pi r squared plus 0.002 times 1200 r to the negative 1 power. Now, instead of continuing to write this slangy sort of notation here, I'm just going to write this down as cost, so C. And it's actually a function of r still, so let me make sure I write it in that manner. There we are, C of r. So this here is C of r. Okay, well, let's simplify this function first. So C of r is equal to, and by simplifying, I'm saying we should be multiplying out what we can. So 0.005 times 2, we end up with 0.01 pi r squared plus, now 1200 times 0.002 will give us 2.4 times r to the negative 1 power here. And we still want to know what the minimum is. So we need to find our first derivative, c prime of r is equal to 0.02 pi r minus 2.4 times r to the negative 2 power. Now to find the extreme points, in this case the min, we need to set c prime of r equal to 0. So that is 0.02 pi r minus 2.4 over r squared equals 0. This can be equivalently written as r cubed equals 2.4 divided by 0.02 pi. Now, if you don't see where I got this, or if you're a beginning calculus student, you should pause your video and use your algebraic skills, that is, flex your algebra brain muscle to go from here to here. So pause the video and try that independently if you don't see where this came from. Okay, so now that you paused your video, you should know how I got from here to here. And then you can use your calculator or try this manually to get that this is actually 120 divided by pi. Okay, so let's finish this up. r is equal to the cube root of 120 over pi. And on your calculator, you should get that r is about 3.368 centimeters. Now let's verify, is this a minimum? For that, I'm going to use the second derivative test again. So that is c double prime of r is equal to 0.02 pi plus 4.8 r to the negative third power. If I put this value in here, this r in here, I'm certainly going to get something that is greater than 0. So c double prime of 3.368 is clearly going to be larger than 0, which is going to ensure that we have a minimum. Okay, so all that's left to do is find the dimensions now. So let me do this here since I have some space. H is equal to 600 over pi times 3.368 squared. Use your calculator to figure out what this is. You end up with about 16.837. So the dimensions, which minimize the cost of materials, are a radius of 3.4 centimeters. And of course, these are approximations, so I'm going to write of about to make it clear that these are not exact. And a height of about 16.8 centimeters. All right, keep calm and calc on, you cool cats and kittens.